Surds. In this module, you will learn about surds. If A is a positive rational number and n is a positive integer, such that B is equal to nth root of A, which is an irrational number, then B is called a surd. Let us consider some examples. The square root of 36 is not a surd because the square root of 36 is equal to 6, which is not irrational. However, the square root of 11 is a surd because the square root of 11 is approximately equal to 3.316, which is irrational. For the surd nth root of A, n is called the order of the surd. A surd of order 2 is called a quadratic surd. Let us consider some examples on quadratic surds. The square root of 3 is equal to 3 raised to the power 1 over 2 is a quadratic surd. However, the square root of 9 is not a quadratic surd because the square root of 9 is equal to 9 raised to the power 1 over 2, which is equal to 3, and 3 is a rational number. Hence, the square root of 9 is not a surd. A surd of order 3 is called a cubic surd. Let us consider some examples on cubic surds. The real number cube root of 4 is a cubic surd, but the real number cube root of 8 is not a surd. This is because the cube root of 8 is equal to 8 raised to the power 1 over 3, which is equal to 2. Since 2 is a rational number, the cube root of 8 is not a surd. A surd of order 4 is called a biquadratic surd. Here are some examples on biquadratic surds. The fourth root of 5 is a biquadratic surd, but the fourth root of 81 is not a biquadratic surd. This is because the fourth root of 81 is equal to 81 raised to the power 1 over 4, which is equal to 3. Since 3 is a rational number, the fourth root of 81 is not a surd. In this module, you've learnt the following. If A be a positive rational number and n be a positive integer, such that B is equal to nth root of A is an irrational number, then B is called a surd. A surd of order 2 is called a quadratic surd, order 3 is called a cubic surd, and order 4 is called a biquadratic surd.